All right, so Brian here from quantlabs.net. More examples of commodity demand storage formulas with C++. All right, so in this set of examples, there's two little algorithms I've added. Here I've added two very simple. It's actually this is going to be now it's more efficient just to do this calculation because it's just a calculation, just a difference between two numbers here that should be probably put in the client testing code that would execute this. But I'm just doing this for just call it inventory cataloging purposes, just as an example. What we're doing here is we're calculating our future differential. So we have our spot price and we have our future price, and all we're doing is just calculating the difference between the future and the spot price. Now here's the thing, is when your future price is lower than your spot price. So basically you have your today's price being the spot, the future's price at some future. When that future price is less than the spot price, then you're going into a backwardation. So that's something you need to be aware of. Also, when you're looking at future contracts, you want to take two different future contract periods, let's say July, September, and you're going to differentiate between the two and basically calculate the spread. So for instance, let's say if F1 is July, F2 is the future price for September, theoretically, and we always will assume that the September price, which is F2, is always going to be higher than F1. So this number, when it gets calculated, the spread should always be positive. If it's negative, meaning the future price of, let's say, the second period of September is lower than the July future price. So that means that you've got backwardation going on, and you don't want that. You want always a future price to be higher than a subsequent future price should always be higher than the previous one. That's just the way futures should be. But you do get backwardation sometimes, and this is just one way to do it. Now again, I've highlighted this note again that these type of calculations are fairly simple. So for cataloging purposes, but you could put them right in the test client code. Okay, just want to make sure people understand that. So as we define everything in the header file, the .h with the proper function signatures as we got here, and here's our main code. This is our testing logic code, or would be, just as a part of the demonstration. And all we're doing is just running those two functions just showed you. So here what we're doing is for the spot future differential, this would be our spot of 3. Our future price would be 3.4, 3.5. So we know the differential should be 0.5. Here the future price is the difference between the two periods of the future prices. So this one would be the first one. So as I said, this is, let's say, assume July. The second one could be September. So in essence, what we want to see is the second price to be higher than the first price of the futures. Otherwise, in this case, when it's negative, when it returns the difference, it's going to be backwardation because now it's negative. So if I run this, you can see here the differential is 50 cents between 3 and 3.50 of the future. And in this case, we've got the first future being higher than the second future, which means in this case it's a 25-cent difference, so we got backwardation going on. Just wanted to show you that and know what it means.